Hello folks, in this video we will learn about HTML canvas. We will first check the basic methods of how to draw rectangles, circles and text. Then we will build this basic character animation. And lastly, we will also build this particle animation where every two particles is joined by a line if they are closer than a certain distance. So without wasting any time, let's get right into it. I have opened the Mozilla Canvas API documentation. And as it says here, Canvas API provides means for drawing elements in JavaScript using HTML canvas element. So we can go down, and the only way to import canvas is by giving the HTML tag canvas. And then if I go down, it says here that this HTML canvas element.getContext method gets elements context, the thing onto which the drawing will be rendered. So once we import this thing, we can start using canvas. So this is how we can start it. And we can go down here, there are some references over here, and if we go further down, there are some additional libraries which is built on top of canvas. So there are many, but in this video we will be covering only canvas. So without wasting any more time, let's go back to our VS Code. And I have three files over here, the index.html, script.js and style.css file. I've already linked the style.css and script.js file, and there is one h1 tag with canvas basics. So let's start by adding canvas. So I will write canvas and I will give the ID of canvas. Now in the style.css I won't do much. I will only give one border of 2 pixels solid black to show where is our canvas. And now I will straight go to the script.js and I will first of all make one canvas variable, and I will identify the DOM where the canvas is, and the ID is canvas. And next thing we will do is we will create one context as we have seen in the documentation, and we will write canvas.getContext and we will pass 2D. So now we can start drawing, and let's also improve the width and the height of the canvas. So yeah, now we can start to see what we can do with canvas. So the first thing we will do is create rectangles, and there are basically three ways to create rectangles. So let's check the first way. So we can write ctx.fillRect, and here we will give 4 arguments, and the first one is x, second one is y, which is our position of the rectangle from the top left. So the top left coordinate of the canvas is 0, 0, and our top left of the rectangle will be whatever is the x and y. So let's give, let's say 30, 30, and the next we have width and height, w and h. So let's give the width as 150 and let's give the height as 80. So now we can see we have one black rectangle. Now what if we want to change the color of the rectangle? We can do it simply by ctx.fillStyle. And let's give the color as green, and let's create another rectangle, ctx.fillRect, and this time let's give the x coordinate as 200, y coordinate as 50, and width is 150, and let's say height is 70. So we got the green rectangle. Now let's explore the second method, how we can create one rectangle. So I will write ctx.strokeRect, and once again we have the 4 parameters. I will give the x as 50 and let's say y as 150, and width as 150 and height as 80. So this time we can see that our rectangle is created with a stroke. So this is the difference between the fillRect and the strokeRect method. Now what if we want to improve the width of the line of the stroke? So we can do it simply by ctx line width equals to, let's say, 5. So we have a thicker line, and we can also change the color by writing ctx.strokeStyle equals to red. So this should be stroke style. So now let's move on to the third method. The third method is not really how to create a rectangle, it's how to clear out a rectangle within a canvas. So let's see by an example. So I will write ctx.clearRect, and I'll write the 4 arguments once again. So let's say I want to carve out a rectangle inside this green rectangle. So I will first give the x coordinate as 210, the y coordinate is 60, and the width and the height will be a little bit smaller. So let's make it 130 and 50. So what we can see is that a rectangle has been cleared out inside this green rectangle, and that is what this clear rect method does. So that's how we can deal with rectangles in Canvas. So now let's move on to our second method, and that is path. So using this path we can draw lines. So now let's save, and first of all I will write ctx.beginPath, and next we will write ctx.moveTo, and I will write, let's say, 30, 30. So what this move to will do is it will identify a point in the 30, 30 coordinate in the canvas. It will not do anything, it will only identify the point. And now to draw a line, what we can do is ctx dot, we can write line 2, and let's say I want to draw the line up to the point 130, 180, 30, and to draw the line we have to write ctx dot stroke. So we can see that one line has been drawn here. And also the same way we can change the line width. So let's make the line width as 3, and also let's change the color. So stroke style, let's make it blue. So what we can see is that one blue line has been drawn over here. So now we can draw some other lines. So once we have written the line 2 up to 180 and 30, the new point has been moved up to that point. So we can draw up to a new point. So let's make it 180, 100, and so another line has been drawn. So now let's draw another line up to, let's say, 30, 100, and to close this we can simply write ctx.closePath. So one hollow rectangle has been drawn over here, and now at last we can also write ctx.fill to fill it with some color, and similarly we can change the color also. So let's change the fill style to, let's make it light blue. Yeah. So what we can see is one blue bordered rectangle, and inside we have one light blue color. So that is how the path methods work in brief. So now let's move on to the next method, and that is arc. So using this arc we can draw circles. So let's clear it out, and now we will write ctx dot beginPath once again, because arc is also treated as a line. And now we will write ctx dot arc. So now it will expect 5 arguments from me. So the x and y is the center of the arc, so wherever we want to keep the center, so let's keep it at 100, 100. And now the third argument is the radius. So let's make the radius as 100 once again. Now comes the start angle and the end angle. So the start angle is from which angle our arc will start drawing, and the end angle is at which angle it will end. So let's start from 0, and we have to end at 360 degrees. So in JS we can write as math.pi into 2. So pi is equivalent to 180 degrees, and math.pi into 2 means 360 degrees. And lastly we have an optional argument, and that is in which direction we want to draw. Do we want to draw in clockwise or counterclockwise? We can ignore it because we are drawing a whole circle. And now we have to do ctx.stroke, and let's change the stroke style before only. Let's make it stroke style to green, and also let's change the line width. So ctx.line width, let's make it 5. So as we can see one circle being drawn at this 100, 100. Let's make it 200, 200. So it's a bit more in the center. So instead we can directly keep the circle at the center. So we have to create 2 variables. Let's say center x, and the center x will be whatever is the canvas width divided by 2, and the other variable will be center y, and that will be the canvas height divided by 2. So now instead of x and y we have to keep center x and center y. So let's keep it center y. First one will be center x, next one will be center y, and also we can fill it. So let's give the fill style as light green, and that's it. ctx.fill. This one will be fill. So we have one green bordered circle, and inside we have the color of light green. So that's how we can draw circles. So now we will move on to our fourth method, and that is how we can insert text. So regarding text, we simply have to write ctx.fillText. That is one method, and inside we have to write one text, whatever we want to print. So let's write canvas is awesome, and the next thing is where we want to keep the x and y. So let's keep it 100 and 150. So as we can see, our canvas is awesome is printed over here. So now let's change the width and the other styles of the text. So we can write ctx.font equals to, let's make it 30 pixel, and let's change the style to Arial. So as we can see, canvas is awesome and the font is also bigger. We can also make it bold by writing like this, and we can also make it bold italic. So now there is a format over how we can give the styles to the text, but this is just an example. So let's make the change the style from Arial to Cambria, because I believe this is better. And also we can do something like this, ctx.fill style, and you have already guessed the result, and that is the text will become red. Now there is this other way to write text, and that is ctx.stroke text, and this time let's write the text as canvas is stupid, and let's give the coordinates as 100 and 300, and we have canvas is stupid. And let's also change the font style and everything. So let's make it bold 30 pixel Cambria, and let's give the line width as, let's make it 2, and also let's change the stroke style to, let's make it blue. So that's how we can deal with text in canvas. And now we will move to our fifth method, and one of the most important methods, and that is image. So first of all, here we have to write one variable, and we have to create an instance of the image, and next thing we have to give the path of the image, and so we have to write image.src equals to, and so here I have already created few images, and that is the sprites run 1 2 3 4. So here first of all I'll use the run 1, this image, and later we will create one animation. So I will write images and then run 1.png. So this is our image, and now to load the image I simply have to write image.onload, and this is how it is checking whether or not the image is loading, and then inside I have to load the image, and that is by writing this method ctx.drawImage, and the first argument is the image, and the next argument is where I want to draw the image. So I have the image over here. So now as you can see, this image is a little bit big, so I want to make it small. So how can I make it small? Is by writing something like this. So first of all, let's write one aspect ratio, and this aspect ratio is basically the image width divided by the image height. And now let's give the image height as, let's make it, let's say 200. And so what is the image width? So the image width will be the image height multiplied with the aspect ratio. So why didn't I directly write the image height and image width? Because I want to maintain the proportions of the image. So after the location of the image, I can write two more arguments, and that is the image width and the image height. So these two are optional arguments, but if we write, it will show the correct image. So we can see the correct image over here. Let's change the y to 80. So this is how we are drawing one image. So now we want to create one animation, or this run animation. So a better way to write this image is using a function so that we can directly call the function whenever we are willing to create the image. And this function we have to call first. Let's give a name. Let's say load underscore image, and let's also give one input, and the input will be path, and this is the path. This is something we want to pass as a variable. So I can call this function load image with this path, and the same image will come. To give an example, if we put run 8, it has changed the image. So now we will move to animation, and for that I will keep this function because I will be using this function to make the animations. And to make the animation we have to make few things. So first of all, I will create one function. Let's name it animate, and inside this animate function I will create something. I will create something called request animation frame, and inside I will put this animate function. And to test that the animation is working, I will console log something over here. Let's say animation is amazing, and let's call this animate function below. So now I will open the console, and as you can see, it is repeatedly printing animation is amazing, so which means this animation is working. So instead of printing this text, I want to animate this image. So how can I do that? So first of all, what we have to do is we have to create some frames, because all of this text that is being shown here, all of this is happening in different frames. So let's name the frame as 0. And also now first of all, what I will do over here is I have the run images from 1 to 8, so I don't want the frame to be exceeding 8. So I want the frame to be going by 1, but when it reaches 8 I want the frame to go back to 1. So I will write I will use the modulus operator, and that is used by %, and I will write 8 over here. And now the next thing I want to do is load this image, and inside I will pass one path. And what is this path? This path is images, and then I have run, and inside this run I will be putting one variable, and that variable is the frame. So now let's see what is happening over here. It is throwing some errors because there is definitely some issue, and the issue is that there should be a .png over here. So now what we can see is that our animation is to some extent working, but it's still yelling at us, and it's saying that run 0.png file doesn't exist. And that is because whenever the frame value is 8, it is being divided by 8, and the result 0 is being stored in the frame, and I don't want that. So whenever the result is 0, I want the value of 8 to be stored over there. So I can write it like this. So now our animation is working, but we don't want it like this. So what we can simply do is, before we are drawing our image, I can simply clear out the whole canvas. So I can write ctx.clearRect. The starting point will be 0, 0, and the width and height will be the canvas width and height. So this is in times like this clearRect method comes in handy. So now our animation is working. But you can say that it is too fast, and you're right. So to slow it down, I can create 2 more variables, and that is character frame and let's say factor. So this factor is by what proportion I want to slow it down, and to do that I can write character frame equals to frame divided by factor. But this is not a whole number, and to make it whole I can write math.floor over here. And again the issue is that sometimes it will become 0, so I will add it by 1. Now instead of frame I can write character frame over here. So now there is some issue still, and that is because instead of dividing by 8 I have to divide it by 8 into factor. So now as you can see, our animation is working very well, and we can remove this. So now you can slow it down or make it fast depending on your wish. So I will leave this up to you. So our basics of canvas is done with this. So now I will move on to the particle animation, and to do that I will simply create another JavaScript file, and I will name it particle.js. So first of all, I'll first comment out these parts, and in the particle.js I will need this part, so I'll copy it, and let's create another particle.js file and let's paste it over here. And in the index.html file, let me import the particle.js and let's comment out the script.js. So now we have the particle.js file, and here first of all we have to create a particle, and to do that I will write a class of particle, and inside this class first of all I need a constructor. So the constructor is the first method that it will run whenever we are creating an instance of the particle. So what are the things we need for a particle? What are the basic things? So the first thing we need is a position, so let's make it x. As of now let's make it 100, and we also need a y position, let's also make it 100. And let's create circular particles, so let's give the radius as, let's make it 10, and the particles will be moving around the screen, so it also has some speed of speed in the x as well as the y direction. So let's give the speed x as 1 and also give the speed y as 1. And the particle may also have some color, but let's not do it right now. First of all, let's draw the particle. So to draw a circle, we know how to draw it. So we will write ctx.beginPath, and then we will write ctx.arc, and the starting point is this dot x and this dot y, and then comes the radius, and that is this dot radius, and then the start angle and the end angle, that is 0, and math.pi into 2. Now let's draw the particle, and we have to create one instance of the particle, so we will write const particle equals to new particle. It has no arguments to be passed, so we can simply write it should be small p over here, particle dot draw. So what do we see? We don't see anything, and that is because we have to write ctx dot fill over here. So now we can see one particle at 100,100 location, but there is no speed and nothing, so let's add the speed and everything. So we will write update. And how to add the speed? So what we know is that we have the x position, and the speed of x is changing the x position, so we will write this dot x plus equals to this dot speed of x, and same for y, this dot y plus equals to this dot speed of y. Now to change the location, we again have to write this animate function, and inside I will put the request animation frame, I will put animate inside, and then I have to call this animate function below. And here what I can do is I can improve the speed. So how can we do that? So I will simply write particle dot update. So why nothing is happening? Because I have to call the draw method in the update. So now what we can see is that our particle is moving, but we know that we don't want it like this, so we will clear out our canvas every time we are updating the particle. So we will do ctx.clearRect, and we will write 0, 0, canvas dot width, canvas dot height. Yeah, so our particle is moving fine. Now we don't want the speed of x and y to be so static, so what we want is some randomness. So I will write math.random, and let's multiply it by 3, let's multiply it by, let's say, 6. So it will give the result in between 0 and 6, but we want the x direction to be both ways, both positive and negative, so I will make it -3. So for y also, math.random into 6 minus 3. So now this time the particle is going here, so we can see that the direction is changing. Now the x and y also need to be randomized, but first of all let's create many particles. So I will write const particles, and it should be an empty array. And now what we need to do is, let's create one particle count. So let's make it particle count, and let's say we want 50 particles. So what we can do is we can create one for loop, and we can start from 0 to particle count I++. And what we can do over here is we can move it over here. And the next thing we have to do is we have to add the particles inside the particles array. So particles.push particle. So now we can remove this particle.draw, and now inside the animate function, it no longer knows what is a particle. So I have to write particles.forEach, and now for every particle I have to update the particle. So now this is good. So as you can see, 50 particles are getting generated. So now I have to add the collision. So whenever the particles are hitting the walls, it should bounce back. And to do that, inside the update method, I will write if, and this is the x position of the particle. Now this is the center. To get the edge, I have to add the radius. So when this is less than my canvas width, in this situation the speed can increase, and it should also be this dot x minus this dot radius. This should also be greater than 0. So this is the zone in between this left wall and the right wall. And so whenever we have this situation, and also we have another situation for the bottom and the top walls, and that is this dot y plus this dot radius. This should be less than canvas dot height. And second thing is this dot y minus this dot radius. This should be greater than 0. So whenever this is not the case, I will have to change the direction of my speed. So I will write when not this, then what I will do is this dot speed x should be changed to the negative. So whenever it is minus, it will become plus, and whenever it is plus, it will become minus. So similar for this one also. So when not this, then I have to change the speed of y. Speed of y equals to minus of this dot speed of y. So let's see. So as you can see, all the particles are bouncing now. So to get this how it is working, you can spend some time on it. So I'll move on with whatever needs to be done next, and that is I have to draw the lines whenever the particles are close. And to do that, I will create another function, and this function will calculate the distance. So I will write function distance. Let's say distance between 2 points, and here I have to pass 4 arguments, and that is x1, y1, that is the coordinates of the first point and the next 2, and y2, that is the coordinates of the second point. And how we can calculate the distance, and that is let's create the x distance, and that will be x2 minus x1. This is coordinate geometry from high school, you should remember. So and for y it will be y2 minus y1. And now I will return the distance, and whatever is the distance, and that is the square root after the squares of this. So math dot square root, and I will add here dx into dx plus dy into dy. So this is my distance. And now inside this animate loop, what I have to do is whenever there is a distance, I have to draw a line. So how I can do that? And to do that, first of all, I'll have to loop through all the particles to check the distance between any 2 particles. So I will have to create one nested for loop here. So let's write for I equals to 0 to I is less than particle count and I plus plus, and then inside I will have to create another loop. So let's j equals to 0, j is less than particle count, then j plus plus, and then comes the comparison. So I have to compare if distance between 2 points in between particle I and particle j. So I have to write particle I dot x, which is my x1, and then particle I, and it is having an issue because it doesn't know particle, because it will be particles I dot y, this is my y1, and now particles j dot x, this is my x2, and particles j dot y, this is my y2. So I have everything, and now I have to one thing needs to be added here, and that is when this is less than, let's say, 100, what I will do here, I will write a line, I will draw a line. So I will write ctx dot begin path, and next thing is ctx dot move to. So where will I move my point? So I will move my point to wherever is my first particle. So particles I dot x, comma particles j dot, no sorry, it will be I dot y. So next thing will be where I want to draw my line. So line 2 will be up to my second particle, so that will be particles j dot x, comma particles j dot y. So now I have to simply stroke. So let's see if it works or not. So as I can see that lines are getting drawn in between particles, so let's try to make it, instead of 100, let's make it 150, and let's see if we have more lines. Let's make it 200. Oh, it's 20, so let's make it 200. Yeah, so we are getting lines, that's for sure. So let's make it 100, and let's increase the particle count to 75. So our particles are working. So now let's also change the color of the particles. So for that I will write another function, and this function is generate random color, and this random color won't accept any arguments because I want to fully randomize the color. So I will create the colors in the HSL format, so that is the hue, saturation and lightness format. So if you want to know this in more detail, I have another video of the color flipper app. You can find it in the description below. You can check it from there, but here I'll just do it quickly. So first of all, I will randomize the value of the hue, which is my color, and that will be math dot random into 360, or 361 is also fine, because this is randomizing the color in between 0 to 360. And for saturation and lightness, let's say in this case I don't want to, I'm just giving some hard-coded values because I don't want to randomize this. And for the alpha value also, let me just give the value of 1. So now what I want to return is a string, and that string will contain the numbers. So I will return HSLA, and inside let me write the syntax. So first argument will be the H, second argument will be my saturation, and this will be in percentage. Third argument will be my HSL, L is lightness, and that will also be in percentage. And the fourth argument will be my alpha value, and that is whatever is there. So I am returning this, and now to draw the particles with this color inside the constructor, I have to get some color, and this color, whatever is there, let me just assign this color. So this dot color equals to color, and now whenever I am drawing it, instead of ctx.fill, I'll just do ctx.fill style equals to this dot color. So now actually we don't need one color argument over here, because I will be assigning the random colors. So now let's see. So as we can see, we have all the particles. Now this black line is coming in between, so what we can simply do is we can do this operation above the circles. So now so there is an issue over here, and that is it is not drawing the lines. So let's keep it down for now. And also here, instead of stroke, I want to give the stroke style also. So stroke style equals to generate random color once again. And yeah, now it looks somewhat better. And as you can see, the lines, colors of the lines are also changing. And now lastly, instead of generating in one point, I want the x and y to be generated randomly anywhere. So I will do math.random into my canvas width. This will generate the x anywhere between the 0 and the canvas width, and for y I will do math.random into my canvas height. Now we have it. Okay, so there should not be this first brackets over here. Yeah, so now as we can see, the bubbles are getting generated. Lastly, let's also fix the line issue. So I'll go inside my animate method. So where I'm updating my particles, I'll update that after updating the lines. So I'll keep it over here. So yeah, the issue is gone now. So our particle system is ready and it looks absolutely amazing. So with Canvas, you can do many more amazing things like this, like create flow fields and also make games. So yeah, that's it for this video. Thanks for watching. Bye bye.